Hello dear students, welcome you once again to the live interactive session of the NEET preparation, the game changer. So in 10 sessions we are going to learn as many fundamentals as possible. Through the lectures we are going to not only cover the previous year questions but also the theory. So stay tuned and keep watching and learn the concepts thoroughly with me, Dr. Pawan Kumar Kasu. Here are there to discuss the fundamentals of the chemistry during this lag hours of our preparation. And today we are going to discuss some more interesting questions, and these questions were asked previously in various NEET entrance examinations. If you are a dropper, that is a long-term student, you could make out last year where you might have made the mistakes. Correct yourself and proceed with double confidence so that you can score as much as possible. Every day at 4:30 p.m. I'll be available to discuss the important topics with the help of the questions. Let's start the session without wasting the time. NEET 10, a game changer program. You know the timings, you know all the details you have with you. Alright, so let's plunge into the discussion. The discussion is related to the preparation of phenols. Like you could see it on your screen, the preparation of phenols. Cumene hydroperoxide method happens to be one of the most important method of preparation of phenol. In cumene hydroperoxide method, you can see the name itself is giving the information regarding the starting compound that need to be taken, isn't it? So you can see over here that if you take benzene, you see I'll be starting from benzene and carry out what you call the electrophilic substitution by using propene in presence of H3PO4. The product obtained is the isopropyl benzene. You know that the pi bond breaks this side, giving rise to the isopropyl benzene, which is commonly known as cumene. So this is the source of the starting compound. This is not the starting compound. Isopropyl benzene is called as cumene. Now this cumene, when subjected to the aerial oxidation, that means in presence of air, when reacted, the most stable free radical, that is 3-degree benzylic, would be formed, which will associate with the oxygen molecule from the air to give you cumene hydroperoxide. That means what? It will be getting 2 methyl groups along with OOH. So this is the starting compound of the reaction. You guys can see that it is present right here, right? Now this will undergo subsequent rearrangement to give you ultimately what you call the desired product, that is nothing but phenol. Benzene will attach with OH and acetone gets separated. So this is the cumene hydroperoxide method, and the answer is option B. Alright, namaste. Alright, chalo, welcome you all. Good answer, Rebecca. Glad you are back. Shall we see this mechanism related to this reaction, right? You know, today's paper is going to be little more trickier than yesterday's or day before. So please stay tuned and keep asking me your doubts, alright? Panditji, so hope you are there with me. Nucleophilic substitution, right? So the nucleophile already carries the negative charge or lone pair of electrons. So when nucleophile is approaching the compound, if the compound has electron deficiency, then only it will invite it, isn't it? Nucleophile is coming with the negative charge. So the compound that is under observation, the aryl halide part, should be having what? Less electrons on it. Yes, Jignesh bhai, that's a brilliant answer, isn't it? You guys can see that if there are NO2 groups, show minus M effect, which will reduce the electron density on the benzene. More the NO2, more is the reactivity at orthopara. This is what you call as Mesenheimer reaction, where preferably the electron withdrawing group must be present at orthopara, then the substitution becomes easy. remember, fluorine substitution is easier than iodine substitution in this reaction. You know that, isn't it? This is the only case where fluorine gets replaced very easily than iodine. However, this is not the point. The point is presence of electron withdrawing group will increase the rate of reaction. So you guys can see, if you are writing the order related to that, you will say that this is most reactive, then you have more electron withdrawing at ortho, then least reactive, lowest reactive is being asked. So yes, you are absolutely correct, Jignesh and Rebecca, brilliant answers. Panditji, I am expecting an answer from you. Next one, good oxidizing agent. That means what? They are taking the electrons, right, from others to get converted into the lower oxidation, that is +2. All right. So when you take the last elements or the F block elements, you know that the lower oxidation states are stable because of inert pair effect. And you can see moreover that these two elements are having +4 oxidation states. So they only have the tendency to take the electrons. So obvious that among the given options, C and D should be the stronger oxidizing agent. What do you say, Anil? What could be the right answer for this question? What do you say? I bet for this. Do you agree? Anything that is striking your mind other than what I said, Rebecca? The point is very clear, isn't it? Point number, inert pair effect, which is applicable to the F block element as well as the last element of the group, which is making the lower oxidation state stable. That means it quickly want to convert into the lower oxidation state. Yes, Jignesh, brilliant. Next, come on. Completely theoretical. Anil, bete. Anil, if my voice is not audible, please check from your end. I'll try to be a bit louder. All right. I think I'm audible, buddy. Anil, come on, speak out. The next question, please. Nothing is striking. So you start, generally when the questions are related to the atomic number and memory related aspects, you start with 1A group element. Probably you will get some help there, isn't it? Start from 1A group elements. Now, what I mean to say, that you have the atomic number starting from 3 when it comes to lithium. After that you have sodium, potassium, rubidium, so on, isn't it? Now you will add 8 to this, you get 11, 8 to this and 18 to this, which is making it 37. So probably you will get some help over there by identifying at least one element that we know. So start from the least, what you call atomic number. So that's my advice to you when you are asked such type of questions. Start from the least, start from 1A. All right. Now you see 37 is the atomic number of rubidium. Yes, you got it. So this is S block element. After that, slowly move on to the next bigger atomic number, 52. All right, you know that when you have 37 here, all right, when you have 37 close to 37 or if you are writing plus 18, it will become 55 related to what you call in this group. All right, so closer by it would be present, and it has been noticed that this is what is oxygen, sulfur, selenium, tellurium. All right, so likewise this is platinums and this is terbium. So like this we have to identify, and accordingly we need to write the answer. You can see A goes to S block, that is 4. So A 4. So these two options are ruled out. All right. So these two options are having A 4, and B 78 is a D block element. Platinum is D block element. So got it. Yes, isn't it? What do you say, Anil? Option C. That's so brilliant, buddy. 13th group element with maximum negative value of reduction potential, right? Negative value of reduction potential. You have to remember certain things related to that. You should know that the least reduction potential value would be for lithium, right? Use the mnemonics. use the mnemonics, anything that you follow. Reduction potential value order is mandatory. So in 13th group, after you can see magnesium, what comes is aluminium. So least reduction potential value in 13th group is not boron, it is rather aluminium. All right. So Al plus 3 will have least reduction potential value. Most negative value means what? Least reduction potential value. You know that if anything has least reduction potential value, its oxidation potential value will be greater. That is the reason why aluminium is used as a very strong reducing agent, aluminothermite process. You know, right? You have studied during your preparation, right? So aluminium is a strong oxidizing agent, reducing agent. That itself means aluminium has more oxidation potential, or Al plus 3 has least reduction potential value. So it's a theoretical question. Good answer, Dignesh. Correct order of electron affinity. You know that when we talk about electron affinity, repeatedly the questions are asked on fluorine and oxygen. Usually electron affinity is more for a smaller atom, but because of extremely small size and more electronegativity, oxygen and fluorine fall as an exception. Fluorine would have been greater than chlorine, but you will see chlorine is greater. Oxygen would have been greater than sulfur as far as electron affinity is concerned, but you will see reverse. Because of excess of electrons that are present on the oxygen, highly electron dense. Because oxygen is highly electron dense, the incoming electron will face a lot of repulsion from the existing electrons because of high electron density, because of which it goes to the last position. So sulfur comes first. So you should have the option, you should search for the option which sulfur is greater, that's all. Rest we don't know. Oxygen cannot be first. Alright, then you have a choice to pick from sulfur and selenium. That's how you will answer it, Avinash. That's a brilliant answer, buddy. Looks to be simple, isn't it? Now coming on to the next question. Chiral optical activity is purely dependent on the symmetry, friends. Symmetry. If the compound has any symmetry element, plane of symmetry, center of symmetry, axis of symmetry, it is regarded as a chiral, optically inactive. If it doesn't have any symmetry element, it would be optically active or chiral. Remember here, trans compound, if you are writing any trans compound, for example, I am writing this trans compound. Bidentate ligand is present over there. Now see, when you take a trans compound, you can see that there is an acute symmetry plane which is passing through the molecule, whether you take horizontally or vertically. So trans compounds are usually a chiral. Brilliant, excellent. So trans cannot be the right answer, right? So these two trans to be first of all ruled out. Then you have cis. In cis you can see one compound is having coordination number 4, and you know platinum complexes, as far as we know, platinum complexes are dsp2 hybridized and are square planar in geometry, and any square planar compound shows no optical activity because it has got a perfect plane of symmetry, right? You can see if I pick this paper, this is square planar. No matter what you keep on the four corners of a square planar shape, you can see along this axis, this is having what you call the plane of symmetry. So square planar does not exhibit, no matter which groups are present, whether they are identical, non-identical, whatever groups are present, square planar does not exhibit any sort of what? Optical isomerism. So certainly the answer for this question has to be this, wherein you can write the two optical isomers of this compound, the non-superimposable mirror images, as this and this, isn't it? So right answer is option B. I think you are following. Anil, can you hear me now? I think you can hear me, Jignesh. All right, now come on, look at this. Copper plus 2 is more stable than copper plus 1, isn't it? What do you all say? Come on, speak out. Bhargav, answer me this question, buddy. I am waiting for you actually. This is your turn. Come on, answer. Copper plus 2 is more stable than copper plus 1 when it comes to the aqueous solution, isn't it? In aqueous solution, the higher charged species is more hydrated. So copper plus 2, wow. You heard it and you read it correct, Bhargav. Absolute presence of mind. You see, usually how interesting the questions in NEET are. Usually assertion and reason are correct. Reason is the correct explanation of assertion, is given as A. You see, to check your presence of mind, they just interchange the A and B options. Have you noticed? You know that copper plus 2 has more hydration. This was asked previously also. So the right answer is B. However, they kept it at this position. Usually it is kept at this position, isn't it, Anil? Alright. So copper plus 2 is heavily hydrated. That's the reason why copper plus 2 is more stable. Good. Yeah. What is KMnO4 in hot condition? Is a strong oxidizing agent. But you know, it is not so strong in acidic medium that it can even oxidize the ketone. It's called oxidative cleavage. Excellent. Today's class is going good because of your response. Brilliant. So what you guys have to do? It's like ozonanalysis. Double bondo, double bondo. That is acetone. Ketones are not so easily oxidized. Ketones are oxidized by hot concentrated alkaline KMnO4. Remember this. Very strong oxidizing agent. So acetone and acetic acid must be the right answer. A should be the right answer. What do you all say? Waiting, buddies. Can you see? Jignesh, is this for this question which you said B? It should not be B. Rebecca, what happened to you? There is no response, isn't it? You can see the next question is little easier ones. You have ethane giving rise to ethyl chloride, alcoholic KOH, dehydrohalogenation, ethene, Sabatier-Sanderens reaction, ethane. So simple, isn't it? So simple. Okay. Next. Which of the following order reaction will have the same units as rate and rate constant? Come on, speak out. What could be the answer? This class is going great. I want to hear answers from you. Looks that you are going to anyways cross 650 and chemistry seems to be that out of 180. Signal problem. Okay, that's okay, Rebecca. Can you hear me now? Yeah. Could you please say something about this? What is the right answer, Anil? Jignesh says D. Wow, what an answer. Where is Anish today? Anish Arya is missing. Weekend vibe. Zero order, Anil. Brilliant. Let's understand that the units of K is mole per liter whole power 1 minus n time inverse. This varies with order. However, units of rate does not vary with order. They are always constant. Mole per liter second inverse. So it is said that the units of rate constant and rate would remain the same when you substitute n equal to 0. When I substitute n equal to 0, you can see they both have the same unit. So it's a zero order reaction. Excellent, Bhargav. That's a good going, Rebecca. Next. Yeah, simple question frequently asked. What transition in the hydrogen spectrum would have the same length, right? Now, what you need to write? 1 by lambda for hydrogen atom. Don't try to substitute. Never ever substitute the Rydberg constant. It somewhere gets cancelled. You just see. Hydrogen is asking what transition. I'll assume some transition from what you call Y to X will have the same wavelength as that of helium. having 2 square and 4 square. So you can see simply that this gets cancelled, approximately assuming to be same, right. So this value will also remain as 1 minus, alright. So 2 square 1 minus 1 by 4, this you can write as 1 by 1 square minus 1 by 2 square. So 2 to 1 A. That's a brilliant answer, alright. Good, super fast calculations, buddies. So right answer should be 2 to 1, right. So hope you guys are following. Good going. Now let's solve this question. Mathematical, little bit of mathematics is involved in this reaction. So you can see that if you take a reaction A giving rise to products, if you start with initially some A naught concentration of this, and after some time the concentration of A becomes equals to some AT, and the product concentration becomes some BT. I will assume that the concentration of product formed is some BT. Now we can see that X mole per liter of A reacted in time T. So X is equal to what? A naught is initial minus AT is remaining. So initial minus remaining is the value of X, isn't it? Now you know the equation, right? You say that the rate law, listen to me carefully. When you write the integrated rate law for zero order reaction, AT equal to minus KT plus A naught. Alright? Okay. Isn't it? Is it so? Or A naught is equal to minus KT plus. So I think it is this, right? So, so you have to write this in terms of that. So what is that you need to find out here? Half-life of the reaction, T half for the first zero order reaction is equal to A naught divided by 2 into K naught. However, you can see that you have been given the value of slope. Now, because the graph is between, so you can see A naught minus AT is equal to K naught into T, that is X is equal to K naught into T. So this, you got 10 minutes, yeah. This equation is in the form of y equal to m into x. Y coordinate is x and x coordinate is t. So slope, you can see y equal to m into x. So slope is nothing but your K naught, that you need to substitute here. That's all. So T half equal to, I am writing it over here, initial concentration is given as 1 divided by slope is nothing but 0.1. So right answer for this question should be 10 minutes. Brilliant. Rebecca, you got it. Bhargav. Good. Yes. Next, the molar conductance of 0. Yeah, you got it right actually. A molar conductance of 0.1 molar weak monoacidic base. Physical chemistry question, so please concentrate a little bit. You know that this is where initially the NEET aspirants fumble. So please concentrate, listen to these concepts very carefully. Now, the pH of centimolar solution is being asked. BOH is a monoacidic base, isn't it? Now pH is being asked. So if pH is asked, you know that this dissociates into BOH is dissociating into B plus and OH minus. Initial concentration of 0.1 molar, you know, you have taken here 0.1 molar. Degree of dissociation I will assume as alpha. So you will be getting 0.1 alpha and 0.1 into alpha. So if I could get the value of alpha, I will be able to find out the concentration of OH minus, hence I will get the pH. That's how I will solve, isn't it? Now listen to me. What data is given to us, please check. Molar conductance of this thing is given, and that is lambda is given, and at infinite dilution it is given as lambda naught. We have one relationship, very important relationship for lambda and lambda naught through alpha. We know alpha equal to lambda upon lambda naught. Very important expression. Please make a note if you are studying for the first time. Lambda is how much? 39.6. Lambda naught is 396 at infinite dilution. So, alpha value you got as 0.1. Therefore, you got concentration of OH minus 0.1 into alpha, that is 10 to the power minus 2. You write in that term because you are applying logarithms. So, you got POH which is equal to negative log of 10 to the power minus 2 which is equal to 2. Hence, we know that pH plus POH equal to 14. So, pH is equal to 14 minus 2, that is equal to 12. Got it? All of you? D option, Anil. 11 कैसे मिला इसमें? Did we miss out something somewhere? 11. Do we get 11 for this or 12? Is there anybody who is getting some other answers to these questions? Rebecca got 12, I got 12. Anil, is this the answer for the question that we are discussing for now, or what's your answer, Anil? In this question, did anything went wrong? 39.6 by, isn't my key correct? What do you all say? Come on, support me in this context. I am waiting. You can see I did not commit any mistake anywhere, isn't it? 39.6 by 396 is 0.1. BOH is 0.1 into 0.1, POH equal to 2. So, right answer for this question is 12. How many of you are with me now? Key wrong. Chalo, thank you, Anil. And now, next question. Yes, that's brilliant. So, we need to identify, we need to make corrections even if there are mistakes in the key. Now, listen, for the same amount of heat absorbed reversibly and isothermally, the increase in randomness at low temperature is more because delta S is equal to Q by T. Whether you type reversible or irreversible, the equation remains the same. If it is reversible, it will be Q reversible by T. If it is irreversible, Q irreversible by T. So, for whatever is the process, delta S is inversely proportional to temperature. So, delta S would be more if temperature is less. Statement 1 is correct. Agree? Statement 2, delta S of system for a spontaneous process is always negative. This is not sure, right? Because when we talk about delta G, listen to me, the sign of delta S, if it is spontaneous, you know that if it is spontaneous, delta S would be negative. So, this value could be negative not only if this is negative, this could be negative or positive. Depending upon the sign of delta H also, this delta G varies. So, if delta S is positive and delta H is positive or negative, even then delta G can be negative. So, looks to be that statement 2 is incorrect. Anil gave the answer. Statement 1 is correct, statement 2 is incorrect. B, Bhargav is right. Stoichiometry is not leaving you, is haunting you in almost every session, isn't it? Listen now, potassium chlorate is a popular reaction. Dissociating or decomposing to give you KCl and O2. Alright. Let's assume some X gram of KClO3 commercial sample is taken, 50% is only pure. By molecular weight is 122.5. These are number of moles of KClO3. I need to have the number of moles of oxygen because at STP the information is related to the volume of oxygen. You know, number of moles of oxygen is volume at STP by 22.4 liter. This is equal to 3 by 2, isn't it? Now we can see 1 mole, how would I get to this? 1 mole of KClO3 giving rise to 3 by 2 mole. If these are number of moles of KClO3, number of moles of oxygen would be 3 by 2 times of this whole stuff. Bas ho gaya. That's it. You have to find the value of X. You got 122.5. The answer is different. Please check. Do the calculation and get it. Next question is also based on stoichiometry. It's based on a concept called as limiting reagent. Let me explain this concept for you by taking a simple reference. See, I am interested in making, I'll write it over here. I am interested in making a moving car. Moving car. For that I will require engine plus body and 4 tires. Alright, what do I require? Engine, body and 4 tire. For example, here if I take, let us assume for an instance, I have taken, let me explain the concept here, concept of limiting reagent. Suppose I have taken what you call 8 tires, 8 body and 8 engine. Engine are 8, body are 8, tires are 8. How many moving cars I can make? How many cars I can make? Can anyone answer? Waiting for your answers. थैंक यू यूवी. बेटे कितने कार बना सकते हैं हम लोग? Come on, tell me. Two cars, isn't it? You see, I took, because you see this will predict if you want to make cars. You guys can see that I can make 2 cars, right? Because each car require 4 tires, so I have 8 tires. That means I can make 2 cars. For 2 cars you require 2 bodies, so 6 body are remaining, 6 engine are remaining. Therefore you say these 2 are excess reagent, excess, and this is what you call as limiting reagent. Please try to understand, don't just give up. So always remember, limiting reagent produces the least. Are you understanding? Produces the least. Remember always, limiting reagent वो reactant है जो कम product देता है. Limiting reagent అనేది తక్కువ amount of product ఇస్తుంది. Limiting reagent produces the least. That's all. This is what you need to understand. So now when you take this, you can see that it's a balanced equation. 50 millimole of ammonium phosphate, 50, and 72 millimole of lead chloride are mixed. Then Pb3PO4 lead phosphate is how much? You should see which is giving rise to least product, and that is your answer. 3:1 is the ratio. If I take this as limiting reagent, I would be getting 72 by 3, 1/3. 3:1 इतना लेता हूँ तो 1/3. 2:1 if I take this much, 50 by 2 millimoles. Whichever is less is the answer. You tell me out of these two which one is less. Raza, you have to check on the description link. There is a Google form. You have to fill it. The inquiry goes to Sri Chaitanya and they will contact you. Please listen. Which one is less? Come on, tell me which one is less. This is 24. This is 25. Isn't it? So this is your answer. Have you understood, Rebecca? Hope you understood. UV. Yes, this is the concept called as limiting reagent. So usually we tend to ignore this. Don't ignore, don't give up. Alright, come on. See, this is another tricky question, right? You know, this is related to the aldol condensation. Now let me explain you how do you write the product related to the aldol condensation. You see, when you listen to me, it's very easy. CH3 CHO. Alright. When you take CH3CHO, 2 moles, alright, I am taking 2 moles of CH3CHO and writing the product. See what will happen, what you have to do is you have to take out the alpha hydrogens only. The beauty of aldol condensation is that it involves only alpha hydrogens. So what is the product obtained? CH3CH double bond CH, CHO. You can see A can be obtained if I take 2 moles of this. How about if I take that 2 moles? Listen to me carefully. CH3, CH2, CHO plus CH2, CH3, CHO. You are supposed to remove the alpha ones but not beta. Many students commit a mistake by removing beta hydrogens. You should not. Yes, I will try to tell you, Bhargav. Stay tuned first. Concentrate here, I will discuss the weightage. Now listen, when you are removing this, what's the product which is obtained? CH3, CH2, alright, CH3, CH2, alright, CH3, CH, CHO, this one. You can see that this is the product obtained if I take 2 moles of this, alright. And what about this? Yes, it is also obtained. How do you get that? CH3, CH2, CHO plus, alright, CH3, CHO. You remove H2O, you will get this as well. But how do you get this? This you would get only when you are involving what? Your beta. You can see CH3, CH2, CHO, sorry, CH2, CH3. That means you see you would get this when you are using which hydrogens? Beta hydrogen. You just check please. But beta hydrogens are not used in, alright, beta hydrogens are not used in aldol condensation. Very good, Bhargav. That's a brilliant question, right? It's a theoretical question. MnF7 cannot exist is a correct statement. Nowhere we have seen MnF7 existing, because you see, you need to understand 7 fluorine with high electron density around themselves cannot be accommodated. They will repel each other. It's a wrong, it's a correct statement. MnF7 cannot exist. 7 fluorines cannot accommodate. Very crowdy. Electron density is very, very high. So MnF4 cannot exist is a correct statement. What else? Mn2O7 cannot exist. Mn2O7 exists because 7 oxygens are around 2 manganese. That's not 1 manganese. So that exists. Right? This is incorrect. CrO3 is acidic. Correct. CrO3 by nature is acidic. That's the reason why it reacts with NaOH, right? So to give you Na2CrO4, isn't it? And CrO is amphoteric. Seems to be wrong, right? So A and C should be the right answer. Yes, correct. So CrO, as far as I know, is basic. Mobile phase and stationary phase respectively in paper chromatography. Mobile and this thing both are liquids. That means how it goes, I'll tell you. Listen, the mixture which need to be qualitatively separated is taken in a solution, dissolved in a solvent. So your substances are present in liquid phase, the mobile phase. Then a paper is immersed and the whole thing is kept in another solvent in which the polarity parameter is judged. So both are liquids should be the right answer, right? Yes. Bayer test, cold dilute KMnO4. You know that the compound which has a double bond or triple bond is added this Bayer reagent, cold and dilute. Remember, this is opposite to what you have studied during the first discussion, where KMnO4 hot will act as a oxidative cleaving agent, whereas cold dilute will just oxidize the bond, does not break it. So you know that the purple color of this will disappear. So this is given by alkenes, alkane, but not benzene, because benzene loses aromaticity, buddy, if it undergoes the addition reaction. So it's not given by benzene. So sometimes questions can be easy. So So that's not my domain. Then please don't post any comment which will offend someone, right? Please, that's a sincere request to you all. Just we are teachers here, right? A teacher here trying to help you as much as possible with selfless efforts. So please concentrate, let the students concentrate, all right? Just a few moments on the what you call keyboard will impact our what you call efforts in the classes. So if you are not liking the classes, or if there is any personal reason, I would suggest you to express your opinion in other terms. But this is a class purely the teacher-student bonding, teacher-student relationship, where students are getting some benefit out of this. So for a teacher, it's always what you call encouraging when the students are giving the answers. We don't need any compliment from the students. What we need just the answers. But if there is any sort of distraction, any sort of negative comment, that definitely temper the momentum of the class. So I suggest you, those who are like having certain apprehensions, having certain complaints, having certain issues, can be tackled in the other platform, other domains, in the other means, but not the ones when the classes are going on. So I sincerely urge the students to concentrate to the classes. If you have some other issues, please tackle them somewhere else. This is just affecting me as a teacher. Nothing else will happen to any other thing. So I suggest you all, please bear with me. Thank you all. Now pKa values, right? So this is where we initially fumble. All right, pKa. Beta will, yes, right, in Aldol. Beta will not be, yes, Rebecca, that's true. Now we are talking about the pKa, isn't it? We are starting with pKa is, don't get confused, right? Minus log of Ka. If you have a stronger acid, please listen to me. If you have a stronger acid, suppose you have a strong acid will have more Ka. If Ka is high, if this value is high, because there is a negative sign, so pKa will be low. And you should know that electron withdrawing group will make a compound stronger acid. So you know that electron withdrawing group is present is in say, so you must identify one compound first, either highest or lowest. Do that first. Don't try to figure out entire order. Before that, check highest or lowest. Probably you will get half of your answer there. So here highest acidic is C. So lowest is that. So you almost got your answer, like C is over here, and electron releasing group, N shows plus M effect. So plus M will have what you call this thing. So B is least acidic, hence pK value is highest. So this is getting tough, right? And after that you have isopropyl, which shows hyperconjugation. So hyperconjugation, what will happen to that? You can clearly make out that the value is next to the electron releasing. Yes, good. Thank you, buddies. Thank you. Yes, I know it happens with everybody here. Everybody has problem with everybody. But Sri Chaitanya is putting efforts to bring you the best in quality on a free platform. Why don't you admit that? And I told you, this is a platform which is making hundreds of students benefited. During the olden days, when there was no coaching, there was no awareness as well, right? People like me or your father, mother who are watching this but have not got the opportunity to get into the top medical or engineering colleges. So it's obvious that now, since there is more exposure, more students are getting into the better positions. But it is you who has to decide whether you will fit into the race or not. It's not the entity's fault. So this is my advice. The entity is doing its best. It is me who has to decide whether I can crawl, climb or jump. If I am just blindly following somebody, thinking that if somebody can jump, I will also jump, there are chances that I might break my limb. So I should know whether I will be an IITian, NITian or whatever. So I must identify my real caliber and prepare accordingly. If I do that, definitely my chances of failure would be less. Instead, what I am doing is that I am just simply following somebody. And when I am following somebody, I will not become him. When I follow myself, I will become me. So you have to understand this fundamental principle called the competitive spirit. So that is what I always suggest to my students. So please, you understand where you are good at. You identify even now what are your strengths. Focus on your strengths, because this is not the time to assess your weaknesses. Every student, even the best of the best person, has certain weaknesses. Who cares? Isn't it? So please identify your strength, work on that. You still have 1 week time left approximately. You can still improve your performance. Good luck. Now listen, just a reagent based question. Halfman degradation, you know that, right? Bromine in presence of cold, this thing, Clemmensen reduction, you know, zinc amalgam and HCl. Canizaro is a concentrated base. Rimateman is, you know, simple chloroform and NaOH. So this set is asked, popular reactions are repeated. Yes, Rebecca, good luck. SN1, as soon as you strike SN1, remember stability of carbocation. That's all, only for one factor. SN2, steric repulsions, that's all. Which one has most stable carbocation? Always remember BAT-SP. Benzylic, more stable. Benzylic, allylic, tertiary, secondary and primary. More benzylic, more stable. More is the reactivity. Thank you. Thank you so much, and that's the culture what we carry. That's so good to see that the students like you are still there, who are understanding the real pain of a teacher. Thank you. Really good to have students like you on the platform, and I mean it. Now you can see that when we are talking about the reaction with HBr, you know, phenol OH doesn't involve in any sort of cleavage. Remember, phenolic OH does not involve in any sort of cleavage because bond energy is high due to resonance. So this goes HBr. That's all. So A has CH2Br and phenol has not gone. And over here also same, phenolic does not break HBr. That's all. So you can see A should be the right answer, isn't it? Bhargav, CH2Br. So you made a mistake here. This will not come, this bond will not break because there is a resonance. You can't break this bond. You have to break this bond. Br goes here, CH3. So right answer should be A. Made a mistake, buddy. So that's all for this session. It was good time spending with you for the discussion, and no offense, all right, either from your side or my side. Please stay tuned, another 5 days to go. From my side, I'll try to give you as much inputs as possible. Please keep watching. Thank you.